Good morning, everyone. Good afternoon to anyone joining us from Europe. My name is Michelle Avila, and I'm your moderator for today's webinar, What to Consider When Purchasing a Light Industrial CNC Table. While you are getting settled, adjusting your volume, I'm just going to go over some quick background information on Hypertherm and some quick housekeeping, and then I will hand things over to our presenter today, Hypertherm's Jim Colt, who is here with me at our Lebanon, New Hampshire headquarters. So let's see. Hypertherm was founded in 1968 in Hanover, New Hampshire. So this year is a very exciting year for us because it's actually our 50th anniversary, and also very exciting because Jim Colt, our presenter, is celebrating his 40th year here at Hypertherm, which is remarkable to be at the same company for 40 years, especially in this day and age.
I was 11 when I started.
Yes, you were 11, of course. So Hypertherm is an associate-owned company with more than 1,400 associates around the globe, and associates, that's kind of what we call our employees here. We devote more engineering resources to plasma cutting research and development than any other company in the world, and are working to continuously improve the cut quality, productivity, operating cost, and reliability of our systems. Our products, Hypertherm has plasma, laser, water jet products. We also have Hypertherm Automation, which is our CNCs and our torch height controls. Software, we have our ProNest CAD/CAM software, along with Robot Master robotic software, and consumables for both Hypertherm and non-Hypertherm plasma, laser, and water jet systems. Today's presenter, as I mentioned, is Jim Colt, who's been here for a very long time, 40 years, and is a wealth of knowledge on just about anything having to do with cutting. So be thinking of questions you want to ask Jim. And before I hand things over to Jim, like I said, just some quick housekeeping. These are questions that I get during every webinar that we do. You will receive a copy of the webinar slides that Jim is going to be showing you today. You'll get a link to watch the recorded version of this webinar. That will probably happen early next week when the webinar is ready to be watched. And that way you can re-watch certain sections or share it with colleagues if you'd like. And in addition, you'll receive a certificate of attendance. Some companies like to track training hours. If your company likes to do that, you will receive a certificate that you can give to your personnel person or human resources. Questions, they are welcome at any time. You'll find probably in the lower right-hand corner of your screen a questions pane that sort of looks like what's on the right side on the slide that's on your screen right now. It'll say questions. You could type your question in there and then hit send, and we will see it, and we will attempt to answer them for you. And that's it from me. So, Jim?
Thank you, Michelle.
Is it not?
Yeah, there we go. Had a little problem advancing the slides, but okay. Thanks for the introduction. Thanks to everybody for showing up, and we've got this presentation is primarily about talking about today's light industrial CNC tables. I know one of the first things, bullet points here, talks about today's industrial CNC tables. Light industrial, entry level, and industrial CNC tables are kind of different segments of the market. They all cut metal, and we'll talk about each one of them. So we'll talk briefly about industrial tables, light industrial tables. We're going to spend most of our time on, and even the entry-level tables, which are even the lowest cost tables, we'll spend a little bit of time on, just so you can see where this technology came from over the years. So developments that have allowed for lower cost CNC plasma tables, we'll talk about. An overview of low-cost CNC machines, ballpark costs associated with plasma cutting itself, if you're looking at this for the first time, and expectations in terms of cut quality, productivity, operating costs, things like that. All these things would really take a lot of time. And so I believe scheduled on the 29th of March, we have another webinar that I'll be putting on, and it's going to talk strictly about the light industrial tables and about the subsystems of each one of those tables, such as torque height control, CAD and CAM, and machine control software that's necessary on all these systems. And we'll get kind of into the nuts and bolts of each of those so that you, if you're considering getting one of these tables for your shop or even for out in your two-car garage, it's kind of where I have mine in my home shop, then, you'll be able to answer those a little bit better and understand what's out there in the market. And deciding factors, which plasma, which machine. We, of course, are going to talk to you about Hypertherm plasmas, and we really developed the whole PowerMax line from our PowerMax 45 XP up through the PowerMax 125 with the specific goal of fitting well and working well for many years on these types of tables. So we can certainly answer questions as far as the plasma goes.
Yep, and Jim, just to interrupt, a quick question, what does CNC stand for?
CNC is actually, that's a good one. I forget to mention that once in a while.
Yeah.
Prior to CNC, back in the 1970s, we had NC cutting tables, and that was numerically controlled cutting tables. And some of those, this was before computers as we know them today, before office computers and laptops and things like that. So NC machines were often a paper punch tape or a punch card that you plugged into this huge controller about the size of a refrigerator, a large kitchen refrigerator, and that was the CNC, that was the NC control for the machine. CNC is computer numerical control. So basically a computer is taking over the work of the punch tape that told the machine what direction to go, how fast to go, things like that. And CNC machines were actually prior to PCs as we know them today and laptops as we know them today as well. They were industrial CNC controls. You certainly couldn't afford one with the new technology that was available many years ago, probably in the late 70s, 80s, and into the 90s. All of a sudden, we've got PCs, and now we've got laptops. What you're going to see is that this is still a CNC plasma, but we're using a standard office computer in a lot of cases with these light industrial tables to power the machine. Okay. So we're looking forward to questions. It looks like we've got a few already, and we'll get to those. We'll try to spend the last 10 minutes or 15 minutes maybe of the presentation to do those questions. And the ones that we don't get to, we'll get back to each and every one of you individually if we can't, if there's too many to answer. So we'll make sure they get answered one way or another. So let's talk first about where these CNC plasma machines that we see at a reasonable price at $20,000 or $10,000 or $25,000 that are available today, where they came from. As Michelle mentioned a couple of times, I have been here for a lot of years, and when I first started, CNC tables were kind of in their infancy. You would only find them in large steel service centers. You'd find them at Caterpillar and John Deere on the shop floor, and you'd find them in shipyards. And they were outrageously expensive. They were huge, and they were, I guess the word would be sluggish by today's standards. They didn't cut as well as they did today, so it was more of a severing operation. And plasma cutters, the smallest plasma cutter you could buy back then from Hypertherm was 400 amps, where today you can put a 45 amp plasma cutter on these tables and cut. In some cases, you can cut almost as good as that 400 amp machine did back in 1978. So. And
they were big. They were like the size of a washing machine, or what'd you say?
Actually, bigger than that. The 400 amp one was weighed just under 1,600 pounds. So you had to lift it with a crane or a forklift or something along those lines. So the plasma cutting technology has really dramatically changed. So these machines, a typical industrial CNC plasma machine today, which are far advanced over the ones that we had in 1978. These are true CNC control machines. They're fully automated today. The operator doesn't have to be an expert and set 24 different settings for height control, for speed, for gas flow controls, for water injection flow control. That's all done actually in the software and in the CNC control. So the operator basically on these machines, big industrial machines, loads plate on the table, squares up the plate, pushes a green button to start. And once the last part is cut, it could be thousands of parts on the table. He unloads all the parts, unloads the plate, and starts over again, just the same way. So he doesn't spend a lot of time pushing buttons with these machines today, where Back in 1978, a typical CNC control console had pretty close to 100 buttons on it, and the operator had to be an expert. So that's what we've really taken away with the new high-end industrial machines today. That's what you find in the John Deere and Caterpillar shop floors, really nice machines today. And these machines can vary in size from 5 by 10, that's a small industrial table, to as much, I've seen some tables that are 40 feet wide by 300 feet long in shipyards. Quite often there'll be 6 or 7 of those side by side in the shipyard, and they run 24 hours a day, 7 days a week. If you can imagine that once a week, a 1,100 foot long super tanker driving out of the bay, that's the type of production that goes on in some of those large shipyards. So often there can be more often 2 plasma torches that run simultaneously, so you can cut twice as many parts. You can see it in the picture on the right side, the upper one. There's 2 torches running simultaneously, but there are a number of systems with 4, and torches up to 800 amps. 800 amps can cut stainless and aluminum to 6 inches thick. However, we are really limited, and we'll talk a little bit more about that on steel, to about 2 inches. It makes more sense on steel if you're over 2 inches thick to use oxy fuel. And very common to see these large industrial CNC machines with many oxy fuel torches sitting right beside on the same gantry with a couple of plasma torches. And plasma torches used for less than 2 inch, oxy fuel above 2 inch thickness. Also, you'll see drills, plate markers, bevel heads, milling heads, things like that are mounted on some of these machines today. Overhead cranes load and unload these tables, and they're expected to run 24/7, 365 days a year with little downtime, and some of these machines can last under those conditions for 15 or 20 years before replacement or rebuilding has to be done. So pretty impressive machines. Each one of these machines has to have these subsystems. They have cam nesting software. Cam nesting software controls all aspects of part drawing conversion, plus virtually all machine motion settings. Now, before you even use the cam nesting software on a machine, first you have to have a part drawing, and that's CAD, computer-aided design. That's pretty much a standard format. The biggies in the industry, would be SolidWorks and AutoCAD, and there's a bunch of others. They all output similar files, they're digital files, and that gets imported into the cam nesting software. And the cam nesting software takes those actual dimension digital cut files and converts them into code that controls the machine. The code actually tells the machine what direction to go, how fast to go, tells the plasma cutter when to turn on, it tells the height control how to function, and can do a heck of a lot of other things. In the CAM software, also, the word nesting means you can have 100 different parts. You need 6 of one, 10 of another, 20 of another, and it can be odd shaped. And what nesting does is it takes all those different shapes and the quantity of all those parts and rotates them around and fits them so that you're not wasting metal. So there's very little scrap space between the parts that get cut. So that's pretty much on every high-end industrial CNC machine, CAD and CAM software. And then these machines also have an industrial CNC control, computer numerical control. This may have a computer inside of it embedded that's similar in design to an office PC or a laptop. However, they're industrially hardened. They have filtering, they have optical isolation, things like that for an electrically noisy shop environment that you typically would find in a big shop. So the industrial CNC is a system brain that controls motion, height, plasma gas flows, on-off functions, acts as the operator interface. This is where the buttons are for the operator. And the trend that you see on industrial CNC controls over the years is, as I mentioned already briefly, that the old controls had 100 buttons on them. The new controls have very few buttons and usually have a touch screen, so they're incredibly intuitive. So this big machine that could be 30 feet wide and 300 feet long, if you can't figure out how to run it, go home and get one of your kids, because a 12-year-old that's used to surfing the net a little bit and doing email will be able to figure it out pretty quickly. That's how I kind of learned how to do CAD CAM stuff in my home shop. My kids were still they were in high school, and they kind of helped me out a little bit. Today I consider myself an expert. Torch height control. This is that they're all industrial CNC plasma cutting machines since torch height control was invented back in about 1976 have had torch height control. The height control controls the torch to work distance while it's cutting for a lot of reasons. One of the big reason is that you get better, more consistent cut quality if you can control the height as accurately as plus or minus 3 or 4 thousandths of an inch of the ideal height that you're going to be cutting at. So a lot of plasma torches run at as close as a 16th of an inch to the plate. And if you vary 3 or 4 thousandths of an inch, it'll cause variations in angularity, dross formation on the back of the cut, things like that. The other things that the height control does is it controls accurately pierce height. Pierce height has to be higher than cut height so that the molten metal blowback while the plasma arc is drilling down through the plate doesn't damage the consumables in the front end of the torch. So it gives you better consumable life. The other thing with height control is it has to retract the torch out of the way to move to the next cut. If you're cutting small parts, one of the parts could have tipped up in the plate and you don't want the torch to collide. So the height control has to be smart and know when to avoid parts like that. But a faster height control can increase cut-to-cut cycle time, which is a good way to save time and get more parts off the table quickly on a high-end industrial systems. Height controls on industrial machines are fully automated. Quite often the operator doesn't even know it has a height control. It's done through the CAM software. So when the programmer's programming the parts, he lets it know it's half-inch carbon steel and that you're cutting at 260 amps, and the height control data that's required, that's different on every thickness and every amperage level, is automatically input. So the operator quite often on industrial CNC machines doesn't have to do anything with the height control. And as we look at the light industrial machines here in a few minutes, you're going to see that's quite a bit different. The operators have to have a lot more savvy to make the height control work correctly, but it's a necessary thing, and we'll talk about why it's necessary when I talk about those. And the cutting power supply, the plasma system. A lot of these CNC machines are very similar to laser cutting machines and water jet cutting machines and oxy fuel cutting machines. Each one's a little different. Each one fits into a little different niche in cut quality and productivity and cutting cost parts of the market. Cutting power supply is very important. So if you were John Deere and you said, look, we need a new cutting table. I need to cut 1-inch steel all day long, and I need the best system for it. We would steer you towards probably either a 300 amp or a 400 amp power supply if it was an industrial application that had to work all day. That's because it pierces fast, cuts fast, gets good consumable life, and it's a big, robust machine. If you were looking at a $25,000 machine, and you said, yeah, I only cut maybe an hour a day, but I got to cut 1 inch all day long, we'd steer you towards a 125 amp plasma cutter. And that's because it's affordable. It's going to fit under that $25,000 or $30,000 cost bucket, but it's a whole different game than cutting with a 300 or 400 amp plasma out on the shop floor. So I'm trying to separate the differences between industrial CNC cutting machines and light industrial CNC cutting machines, and we'll see more detail on that as we go on. So industrial CNC machines constructed for rough industrial duty for many years, 3 shifts a day, use the latest motion and drive technologies for excellent mechanical accuracy and reliability, designed and built for many years of accurate high productivity cutting. And I will say cost is almost no object on these machines. So some of these high-end industrial CNC machines can cost as much as $1 million, like those big shipyard machines I'm talking to you about. And they start at probably just under $100,000 for a small 5 by 10 table. So if you look at the cost per foot of cut over 20 years of use, they're probably a bargain. And they make these companies a lot of money. So there are as many as 85 worldwide manufacturers of industrial CNC cutting machines worldwide, probably actually more than that. There are 85 that I'm aware of. Most OEM machine builders cater to industrial plate and sheet cutting markets. And something I don't have on this slide, there has been a pretty fast-growing trend of more than plate and sheet cutting, but to get into structural steel cutting, coping, I-beams, and things like that with kind of robotic type machines that are much more complex than just for cutting flat plate. Virtually any size cutting bed is available. Fumes are controlled with either a water table or downdraft. More about that later, and more about that at the webinar that we're going to do on the 29th. Vast majority use Hypertherm plasma. We have been popular systems for the last 50 years, and worldwide we do have market share, and there's a lot of good reasons for that. We're not going to spend a lot of time on that today. We're talking about cutting machines. Most use industrial PC-based CNC controls today, but it's an industrial PC that's hardened for electrical noise interference, and most are built to last very robust to last 20 years in an industrial high-duty cycle environment. Dramatic performance enhancements over the machines that I saw many years ago. So the pictures that we show here are not all industrial CNC plasma machines. In fact, upper left corner, that's an entry-level machine, and it's here just to kind of show you the difference. That's a 4x4 table in the upper left corner, a pretty popular one. And if you look in the lower left corner, that's actually a little demo machine. Typically, that would be 5x10 or 6x20 or 150, 6x150 feet. That's a machine that's showing multiple oxy fuel torches along with one plasma torch for a really wide range of cutting. So upper left corner, that machine can be had for around $12,000 without the plasma. With plasma, probably around $15,000 total. The lower left machine, if it was in a 5x10 size, would probably be $120,000. So there's a big difference from a price point of view. But you can also kind of see in the construction, crane rails that mount on the floor on some of these machines, where the upper left corner machine is pretty lightweight construction. It's a similar machine to the one that I have in my home shop in the upper left corner. I probably couldn't afford, and my wife wouldn't be able to park her car in the garage if I had one in the lower left corner. So that wouldn't go over well. So, okay, so industrial CNC plasma expectations. We kind of covered all this. I'm going to skip this slide, except for take a look at the picture. You can see parts cutting very rapidly on this machine and cutting with 2 torches simultaneously, so that doubles your production. This is a shop in Canada that I visited a few years back. Most of this steel is 3/4, 7/8, and 1 inch thick, and this was production from 8 o'clock in the morning until noon. Everybody was gone for lunch. These would all be packed up and out by the end of the day. That's really high productivity that you won't see with a laser. You won't see it with a water jet. You won't see it with oxy fuel because of the speed difference, but you will see this with plasma. This is what plasma is. We used to say plasma is productivity, but I don't think we use that.
No, we don't.
Slogan anymore. So, okay. So now let's switch a little bit to the low-cost CNC plasma machines. Technology improvements over the past 40 or so years, especially with motion controls, PCs, personal computers, and air plasma cutting, have led to a really robust market for low-cost machines. 40 years is when the technology improvements have come along, but we figured out how to make low-cost machines that almost anybody can buy. And I like to say it's cheaper than a bass boat. So maybe instead of buying that new bass boat, you might want to look at one of these machines. You can make parts for your 4x4. You can make do artistic wall hangings. There's a lot of people doing those things. These have all occurred in the last 20 or so years. What this technology and motion control and software and things like that needed and what had to wait for was developments with the plasma cutters and developments that allowed personal computers and laptops. So we needed those. And I don't know, that's 25 or 30 years ago since laptops and personal computers really got to be a household appliance. What had to happen with plasma was all of the industrial plasmas and all of the early plasmas used a starting method to get the arc started in the torch called high frequency. And what high frequency is about 15,000 volts of high frequency energy that's used to create a spark, a very intense spark inside the plasma torch that ionizes the gas and gets the plasma cutting process started. The problem with that high frequency and high voltage is if you get it even within close proximity to a laptop or a personal computer that's made to work in an office, it'll shake up the low voltage circuitry in that computer. It might even make smoke come out the side of your computer. So what plasma needed was a different starting method, and Hypertherm actually patented a process called blowback starting technology back in the early 1980s. And it was a way to eliminate high frequency starting that used a moving electrode inside the torch. So a spring-loaded electrode that the air pressure would actually move the electrode back, create a short circuit spark, and fire the torch. Little did we know that this was going to help this whole market with low-cost cutting tables. We just thought it was a better way to fire the plasma torch, more efficient. They allowed us to make smaller, more efficient, and more accurate plasma cutting systems. So blowback starting technology, non-high frequency starting. So what a few engineers out in the field decided that, hey, I've got this plasma cutter that doesn't make that much noise anymore, and I've got this PC, this computer. Now all I have to do is write some motion control software that goes into PC. I've got to make a circuit board called a breakout board that takes all those signals, electrical signals from the PC, and turns them into direction and speeds and information for the plasma cutter and for the height control and all that. I bet you I could make it really cheap, really low cost CNC cutting table. And so about 20 years ago, there are two companies, I won't mention the names, but they're big players in this light industrial market today that kind of entered the fray, came up with some really nice little machines. They're antiques by today's standards, but they started this whole thing with low cost CNC plasma cutting machines. Today, there are more than 24 manufacturers of low-cost CNC machines, 24 that I identify here in North America. That's in the U.S. and Canada. I guarantee you there are more than that in China and other parts of the world. And actually, there are more than 24 in the U.S. and Canada. There are 24 that I'm aware of and I've actually worked with, and we've installed our plasma cutters on. These lower cost machines offer great technology and performance for small shops, metal artists, hobbyist types that previously could not justify the cost of a CNC cutting machine. Cheaper than a bass boat. New companies have emerged. Few industrial machine builders have entered into this market. They've kind of like the industrial builders kind of like to build their large industrial machines. And a few of them kind of look at these machines as more of a toy or a small machine. However, I have seen some of them start to lean this direction. They're looking at the large numbers of these machines that are getting out into the market. So we saw this slide already, but you notice the wording's a little bit different. These light industrial CNC plasma machines need these same subsystems. They need a CAD drawing, they need CAM software, they need a CNC control. But instead of using an industrial CNC control, they use a regular PC or a laptop in most cases. They still need torch height control. There are machines available without torch height control. We'll look a little bit briefly at what not having height control or having height control that doesn't work good does to you today, and we're going to spend more time on it on the March 29th webinar that we do. And the power supply, and the picture of this power supply, I didn't change it. This is still an industrial power supply. What you would see is an air plasma cutter that uses non-high frequency start. And those are typically limited to up to about 125 amps, but you can pierce 1-inch material. You could, in theory, edge start and cut as much as 2-inch material with that. But once again, we don't recommend it for 3 shifts a day type operation. If you're going to do that kind of work on 1-inch material, we're going to steer you towards an industrial heavy duty machine. So these machines are constructed for light duty, hobby use, less sophisticated motion and drive technology as compared to industrial machines, and they do that for lower cost and designed so anyone in the shop can draw and cut parts depending on the capability of the person, and at least a minimal amount of training. Generally, if you've got a young person right out of high school working in your shop, they're going to walk up to these machines and figure them out with no training. Those with a little bit less computer savvy are probably going to take just a little bit longer. That's my observation out there. So just while I'm on this slide, briefly want to mention, think about the John Deere shop floor. The supervisors there want to see, they need to get a certain number of parts cut every shift so that they can build their tractors and get them out the door. Do you think the operator is going to be pushing buttons on the CNC control, drawing parts that he's going to cut on the machine? No, you're not going to see that. However, in a small shop, a little welding shop with 4 or 5 employees, or maybe 20 employees, or maybe just 1 employee, you're going to want everyone in the shop to be able to walk up to these light industrial machines and actually draw your parts if you want to. If you're building, repairing a horse trailer or something like that, and you need to make a little gusset that needs to be welded onto the frame, you want your welding guy to walk over to the machine and be able to, in 5 minutes, draw the part and cut the part and be welding it back on the trailer. And that's what these machines really shine at. So they're more operator intense machines, where the large industrial machines are more automated with kind of a button pusher, part unloader operator on those machines. I shouldn't really downplay the operators. That they're pretty sharp on these machines, because it's an expensive machine and such an integral part of every factory. They aren't just button pushers. They're a little bit more than that. But we've kind of taken a lot of the expertise that can cause poor cut quality and things like that out of the high-end industrial machines. And we're going to see the low-end machines are going to get better and better too. But it does, the technology hasn't been developed to fully automate the light industrial machines. But I'm willing to bet in the next 10 or 15 years we're going to see some much better capability, even on the light industrial machines. Okay, the market for these light industrial machines, and this is showing just a few pictures of them. We've kind of taken the names off these machines. We're not going to talk about specific manufacturers, and that's because Hypertherm works with all of these manufacturers, and the ones that have Hypertherm plasma on them are certified good machines that we work very carefully with these guys. So the market has exploded in the last 10 to 15 years with a variety of brands, models, and options. There's a lot of different ways that you can get these machines. One is to buy one, and there's a couple different ways you can buy them. You can buy them turnkey. They're in a big crate. They're on a truck. Shipping costs are pretty expensive if you bought a 5x10 machine and had to ship it across the country. And some other machines are disassembled when you buy them. And almost everybody I know has bought a gas grill at the local hardware store or at the Walmart and brought it home, and about a 6-pack of beer later and about a few choice words, you probably have it assembled and ready to go. But there's a lot of pieces. Well, these machines are probably a little nicer than that. They have the hardware is all supplied, the holes line up, everything works pretty good. But you can buy them, many of these machines broken down, put them together, save assembly cost, and put them together that way. Buy a turnkey machine, and then last but not least, is actually a fairly good sized market for do-it-yourself machines. If you've got the skills, if you've got light electronic knowledge, if you've got good welding and fabricating skills already, as many people that are going to buy one of these machines do, and you've got access to that stuff, you can build your own machine. You can buy the motion mechanical components on the machine. You can buy software. You can buy CNC controls that are made for these light industrial machines and actually save a lot of money. So I've seen some people build 5x10 tables for really decent, reasonable prices. So let's kind of take a quick look. Now this is one of the more popular light industrial tables. It's a 4x4 table. When you buy it, it's in a crate on the left, relatively small size. Open it up, count the parts like you would with anything like this. Start assembling, read the directions. Close in the base for downdraft fume control to take care of the smoke. We're going to talk more about that on the 29th, more than we do today. Plug in a standard PC, load software, connect to a plasma system. With some of the Hypertherm systems, it's plug-and-play connection with these machines. Basically, you just twist in a plug on the back of it, connect the torch, mount the torch on the machine, and you're pretty much ready to cut. This machine that you can see in the picture here sells for somewhere around 12 to 12.5 K, and without the plasma cutter. So and if you put a PowerMax 45 XP on it, you're going to add about $2,400 with a machine torch. So pretty nice way to get started in this business. This particular machine is also sells for around $12,500, 4x4 cutting bed, and it comes fully assembled. This particular one came fully assembled in a box the shipping was around $1,400 to go from the West Coast to the East Coast with a machine like this. So that's one of the things that you have to take into account when you're looking at it, if you're looking at prices. Add assembly, add water in the water tray, and this one has a water tray fume control. So the difference between downdraft and water tray, there are pros and cons for each. If you have a downdraft, you have to have a blower and you have to blow the fumes outside or through a filtration unit. If you're blowing them outside and you live here in New Hampshire where it's frigid, it seems like 13 months of the year, it's what you're doing when you're blowing that smoke outside is you're sucking cool air somewhere else inside your shop, and it kind of takes the heat away. So other than that, though, downdraft tables give you a little bit better cut quality than water tables. Water tables actually blow the molten metal and the fumes down into the water. That cools the molten metal, and they sink to the bottom of the water, and that takes care of most of the smoke. With the water table, though, you get some splashing on the moving parts of the machine. You get a little bit rougher edges and a little bit more dross. So it's kind of a balancing act. We'll talk once again more about that on the 29th, or contact Jim Colt at Hypertherm, and I'll help you make your decision whether to go with downdraft or water table any day of the week. So prepackaged component kits, there are companies that make the electronics. So you kind of see on the left of this picture, you use a regular that's showing a laptop, or down below you can see a PC, plasma cutter on the right, and then there's a box with all the electronics for height control, motion control, and things like that. That would be from one company that sells just the electronics. We can steer you to 2 or 3 different companies that do that if you want to build your own table. And on the right, there are at least a couple of companies that build the frames for the machine. So most of the components, you're going to have to do a little fabricating and a little bit of welding. But by the time you get it all bolted together, it could look like this. You've got a home-built table. You understand the machine pretty well because you put it together yourself. But you're going to have a lot more time. If you bought a turnkey table, you'd be cutting the first day you had it. With one of these, it might be a month or so by the time you get it all together and get it all figured out. So those are the things you have to think about with these light industrial tables. So selecting the right CNC machine, which features should I get, which plasma systems to use, what else do I need, what tolerances, accuracy, and cut quality should I expect? Let's take a look. Low-cost CNC plasma machines are low-cost for a few reasons. They're smaller in size, they're considerably lighter in construction, they use a standard office PC as a CNC control, they're limited to lower-cost, non-high frequency start air plasma cutting systems. Cut quality can be very nice, but expect more operator supervision and expertise as compared to the high-end industrial plasma cutting system. Seems just the opposite of what you'd expect, right? A homeowner machine or hobbyist type machine should be easier to run, but unfortunately there are a lot of settings for plasma cutting, for height control, for speed control, and you got to learn a little bit of CAD drawing and how to control the software. Not difficult, but those are some things the operator has to have expertise, just like they did years ago with the high-end industrial tables. Learning curve in regards to setting important parameters such as pierce height, pierce delay, cut height, arc voltage, amperage, cut speed, corner speeds, as well as doing a CAD drawing, understanding what you can cut with plasma and what you can't cut with plasma. It's not the same as a line drawing. You can't cut all the lines because the center parts will drop out. So there's some learning that does have to be done. Once again, not difficult. And many of the manufacturers of these machines have great educational programs. You can actually go to their websites and download videos that show simple steps, kind of fast steps to get into CAD drawing and using the CAM software and so forth.
Yeah, and I don't want to scare anyone away, but just the Hypertherm Owner's Manual does give people a starting point as well, as far as the amperage and the cut speed and all of that's in there.
And that's a good point, because I get questions online every single day of the week. Like, okay, I'm going to cut some 14 gauge hot rolled steel.
Yeah.
What do I set everything at? And that's when I say, first you have to go back and get your operator's manual and open it up to the page. That there are as many as, in a PowerMax 65 as an example, there are 33 pages of cut charts in there for all the different thicknesses and types of metal, and tells you everything that you have to set. And that's, interestingly, one of the biggest issues we have with cut quality in the field is not opening the manual.
Yes, not following the cut chart.
And I'm a perfect example of that. So, Not with plasma cutters though, but with everything else. The manual is the last thing I'm going to look at. So open those manuals up and take a look at them. So torch height control. What does height control do? Again, this is a better subject to cover on the 29th, but all plasma cutters produce the best combination of cut quality and consumable life if pierce and cut height are accurately maintained. Pierce height allows the plate to be pierced without molten metal that can damage the torch consumables. Height controls lessen edge angularity, dross formation, and material warpage. And in order to control the edge angularity, dross formation, and warpage, we need to maintain the height within about plus or minus 10 thousandths of an inch during the cutting process. So if the cut charts in the manual say to run the torch at 60 thousandths of an inch off the plate, it's got to be between, within 50 to 70 thousandths off the plate. There's not a piece of material, 14 gauge steel, that flat on the planet. So you need a height control in these machines to make sure the torch stays at the right height. Do I need a height control? Some of the low-cost machines are sold without a height control to reduce the purchase price, and they have options where you can add a height control to it if you want to at a later date. I don't recommend that. A lot of people buy machines and don't listen to my recommendation. I understand that. Lower cost, if you want to do that. But usually I get calls within a few weeks asking how to improve the cut quality and improve the consumable life. And those are things that are directly controlled by the height control. Machines without height control, the operator must continuously monitor the torch to work distance and manually set a higher pierce height when you're piercing on thicker materials. It's virtually impossible to maintain that looking at it with your eyes. You can cut parts without height control, but expect shorter consumable life, worse cut quality, lower productivity. So one of the key features on a CNC cutting table is a good quality height control. Okay, so all of the decent manufacturers of CNC cutting tables offer a fully functional height control system. I guess if you had a strict budget, you didn't mind cutting one part at a time and spending half an hour or 45 minutes cutting one part where you could do it in 5 minutes with a height control machine, then yeah, it might be a good way to get started, as long as you know that there is a better way to do it. A good example that I do with my home shop, I had a buddy that needed a bunch of shims cut for some job that he was working on, 800 to be exact. They were all small, cut out of 10 gauge steel. And I was kind of busy, but he had insisted on a Saturday. He brought the steel up, and he says, I'll watch the machine. He didn't know how to run the machine. Anyway, so I set it up, tested 800 parts on this one sheet of steel, and then I went and proceeded to mow the lawn, which was what I was supposed to do on Saturday. And the machine cut the parts. When I was done mowing the lawn, it was done. You cannot do that without height control. There would be a collision, a broken torch, and some choice words probably when you stop mowing the lawn. Okay, so features to look for. There are cutting tables in the light industrial market, 2x2. And up to 5x10. There might even be a few bigger ones, but that's the majority of them are 2x2. The most popular are 4x4 and 4x8 and 5x10. 2x2 tables, when you think about it, steel comes in 4-foot, 5-foot, and 6-foot widths. Those are standard widths. So if you've got a 4-foot table, you can buy a 4x8 sheet of steel and kind of get half of it on the table and support the other half of the steel plate until you're ready to cut that. With a 2x2 table, you have to buy steel and cut down to 2-foot size, and your steel supplier, in most cases, is going to charge you for that, so it's going to cost more. And if you have to cut larger parts, it's difficult to do on a 2x2 table. So everybody looks at a 2x2 and a 4x4 made by the same company. They use all the same drive motors, all the same electronics. Everything's the same, except there's a little bit more steel on the frame of the machine on a 4x4 table. So 4x4 does not cost 4 times as much as a 2x2. It costs just slightly more. So if you got the room, get the 4x4, get the larger table. Will make a lot more sense. So I already talked about this. I'm gonna kind of skip over this slide once again on the 29th. This is really just talking about downdraft and water tables or water tray type fume controls and no fume control. I don't recommend no fume control. My shop is 36 by 40 with high bays, and trust me, if you don't turn on the fan on the downdraft filter, you will fill the shop up with smoke in about, I'd say probably 45 seconds. I've done it before. Forget to turn the fan on. So, and then you've got the little particles of plasma cutting dust all over everything in your shop as well. So you need fume control, water table, or downdraft. And air plasma systems, critical consideration, blowback starting system if your table uses a PC or laptop as the machine controller. Should not have a machine torch, should have a machine torch. Adapting a hand torch is not recommended. There are some manufacturers of cutting machines that have come with hand torch mounts. The problem with putting a hand torch on a machine, it will cut the same as a machine torch, assuming you have the torch perpendicular to the plate, but it's almost impossible to mount a hand torch perpendicular. And you quite often have to pull the torch off the machine and change consumables. If you're cutting thicker material, you need a different nozzle on the torch, or inspect the consumables. If you blew some molten metal back on the front end, you might want to inspect it to make sure there's no damage, so you get good cut quality. With a machine torch, it's a lot easier to mount the torch on the machine than with a hand torch. So that's what we recommend, and we can steer you in the right direction. Air plasma systems, capacity ratings. Take a look very carefully at the capacity ratings, because many of the air plasma cutters, including the Hypertherm PowerMax line, have different capacities when you're hand cutting as opposed to machine cutting. That has to do with the pierce capability. When you're hand cutting, your hand is kind of like a 6-axis robot. You can tip the torch at an angle and pierce through some fairly thick material. On a machine, the torch is held perpendicular to the plate, and the material blows, if not done correctly, blows right back on the front end of the torch. So typically, a machine, let's say a PowerMax 45 XP, that's probably not the best example. Let's use a PowerMax 65 because I know the numbers for it. The PowerMax 65 for hand cutting, we actually rate it as a 1.25 inch thick machine. You can edge start using the right technique. You could actually pierce 1.25 inch with a PowerMax 65. And when you buy it as a machine mounted torch, we recommend it at 5/8 of an inch. So the rating is half. I could still edge start on a CNC machine with a PowerMax 65 and cut 1.25 inches. I've done it. But if you're going to be piercing, you want to keep it at 5/8 of an inch or under. And that's for consumable life, cut quality, things like that. Right? So we won't have to go through all the details on the plasma cutters as far as capacities, but you can find these on this come right off the Hypertherm website. You can find it on the brochures, what the recommended capacity, pierce capacity is what you want to look at for CNC cutting tables for each one of the machines. This shows the 45 XP, the PowerMax 65, PowerMax 85, and 105, and there also is a PowerMax 125. Now, Hypertherm does make 2 30-amp systems as well. We do not make machine torches or machine interfaces for them. Those are recommended for handheld cutting only. That being said, there are a number of people that have adapted them to machines, but you need to keep them on pretty thin material if you're going to be using a 30-amp system, and you won't get a lot of support from Hypertherm Tech Service if you call and say you've got the PowerMax 30 XP on a CNC cutting table. I'll help you as much as I can, but Tech Service, that's a handheld torch to them, so keep that in mind. The 45 XP is really the best choice for the smallest plasma on these machines. The interface on these PowerMax air plasma systems, if you're building your own machine, is simple. There's 3 inputs and outputs. There's the plasma start. There's basically it's a contact closure from the CNC control that starts the plasma arc. There's arc transferred signal. That means that the arc transferred to the plate and has started the cutting process. That's used in the CNC machine to start the height control, start the machine motion, things like that. Then there also is the divided arc voltage output. So we take the arc voltage that's used for height control functions to control height when you're cutting, and we divide it down to a safe level. Other plasma manufacturers keep their arc voltage at high levels, which is kind of dangerous, up to 300 volts DC. So anyway, those are typical interface signals. Skip these as far as operating cost and so forth goes. Michelle, do we have some questions that we
have a lot of questions.
Yes. Let me just buzz through a couple things real quick here, and we'll get right to those. So, what to expect? with plasma cutting. These are actually all parts that were cut on my home shop machine. Some of the signs, I think 7 of the signs in front of Hypertherm facilities here in New Hampshire are cut out of 1/4-inch stainless steel, 5 feet wide by 3 feet tall. The letters are cut out. I actually did that on my home table a number of years ago. The next parts over from the left, the second ones from the left, those are parts for a buddy of mine. He needed parts to build a log splitter, 1/2-inch steel. That's about a 20-minute project at home on a Saturday morning. The next parts, those are interesting parts. Another friend of mine was building zip lines for his kids, and this is a seat that goes on the zip line that you could jump off the front lawn, get on the zip line, and deposit yourself in the lake on a summer day. So it was great. And of course, just showing how easy it is. This was actually Mickey Mouse that was scanned out of a kid's coloring book, scanned right on a regular printer scanner, imported into the software as a JPEG, and converted almost immediately into a cut path. So a lot of use, a lot of easy use. And this is one you actually get some brownie points every once in a while. This is my wife with her passion. Well, it's actually 3-phase eventing on her horse, and couldn't think of what to get her for a birthday present one day, so I took that photo and turned it into a little bit of metal art. And the name of the horse is Indian Summer. So a lot of things that you can do. This is metal art. The other things are more what I call these are more like geometric parts, with the exception of the Mickey Mouse on the right. But there's a lot of applications for these machines. So low-cost tables can produce high-quality parts with minimal setup and drawing time, can produce low to medium production runs at low cost per part. Nothing's lower cost per foot of cut than plasma when it comes to cutting steel, aluminum, and stainless steel. Typically, whole cut part accuracy is in plus or minus 30 thousandths. So if you're really babysitting the machine, you can hold a lot better tolerances than that, but that's what would be expected if you're cutting a few hundred relatively complex parts. So this one, maybe you want to talk about?
Well, this is just showing that there are more ways to learn. You can visit our website, www.hypertherm.com. I think we should jump right into questions, just because there are a lot, and time is short. So maybe Jim, just ask you to keep your answers brief. But you mentioned blowback start several times. Someone's asking, do you mean pilot arc start? What's the difference there, blowback versus pilot arc?
No, actually, a blowback start is a pilot arc start, but a high frequency start on some plasma torches is also a pilot arc start. So what a pilot arc is if you fire the torch in the air, you see an intense blue flame that comes out the front end of the plasma torch. That's a pilot arc, and a blowback torch and a high frequency torch both do that. Okay.
Do you have any thoughts on the Pro Plasma from, it looks like a company maybe called CNC Router Parts? They are considering moving to a CNC router parts table from their plasma cam.
Well, I have a lot of do-it-yourself builders source some of their parts from router parts. There's a few companies out there. PrecisionPlasmaLLC.com makes a lot of the parts for these tables and can tell you where to buy them. Router Parts is also a place where you can get drive boards, electronics, some height control stuff, things like that. So that's about as much as I know about them. I've never actually worked directly with them, but they're worth taking a look at. And also, when you're thinking of building a table, feel free to contact me. The best way is via email, and I can offer you advice from what I hear from literally thousands of other builders over the years. So.
Yeah, and it would be jim.colt@hypertherm.com. I know that you mentioned that earlier. And be persistent. Jim is very good about answering emails, but he's also extremely busy. So let's see. Will your plasma CNC cut holes for number 8 pass-through holes?
Number
8.
Number 8. So you probably talked about a number 8 bolt size, or I'm not real sure.
Yeah, maybe a little more.
I mean, bolt sizes go 832, 1032, 632. An 832 bolt, if I remember correctly, is just under 1/8 of an inch in diameter. That's if the plasma can do it, but it can't do it by itself. So it needs good motion control, good height control, and things like that. So if you put it on a machine that's loose and sloppy, no, it won't. If you put it on a machine that's tight and can help control the tolerances and you choose the right process with the plasma cutter, yes. So.
Okay. Another question about a specific table, thinking about a Bailey PT22 CNC table. They have a PowerMax 45 that needs a control board to interface with the table, and they're wondering if this is already contained in the PowerMax 45. It would depend.
Yeah, well, if you're using any of the Hypertherm PowerMax systems, the PowerMax 45 XP, the PowerMax 65, 85, and 105, you do need, if you're going to be using a machine torch with it, you do need the CPC voltage divider upgrade for it. You can actually buy that and install it yourself in the field if your PowerMax does not have it. So yes, you could put a PowerMax 45 on there, but it probably, now if it's the original PowerMax 45 that doesn't have the XP suffix, you have that already. It's on the original 45s. On the newer PowerMax 45 XP, it's an option. You have to buy it, and it's I think it's around $120, available at most any welding distributor that sells Hypertherm.
What would cause a torch height control to not operate at the recommended voltage? Voltage says it should be 118 amps, but my torch height control moves the torch inches off the plate.
Yep, that's common. In fact, I answered a couple of questions about that this morning. That the height controls all operate off feedback arc voltage. So they read the voltage from the plasma cutter. And the way that works, if you're going at a fixed speed, say you're cutting at 100 inches a minute, and you increase the voltage, higher voltage equals a longer arc. So it's going to move, the Z-axis will actually move the torch up further away from the plate. If you decrease the voltage, it moves down. Now, also, if you're cutting along at a fixed voltage, the torch will stay at a fixed height off the plate. And let's say you lower the speed. Lowering the speed affects the voltage height relationship. So when you lower the speed, expect the torch to dive closer to the plate. Increase the speed, the torch will rise off the plate. So voltage doesn't mean anything. We don't care what the voltage is, as long as the voltage is correct to maintain the right cut height. So on your cut charts, it's going to give you a voltage and a cut height. What you want to do is adjust the voltage so that the cut height is correct at the speed that you're cutting at. And there are a lot of height controls out there. Some are more accurate than others. Some you set at exactly the arc voltage that is listed in the Hypertherm cut charts, and others you have to offset them a certain. I've seen some of them that are off by as much as 20 volts. So if our cut chart says a cut at 110 volts, often you have to run at 130 volts to be at the right height. So, but don't worry about that. As long as the cut height matches the normal cut height, and the most common cut height with a Hypertherm PowerMax unit is 60 thousandths of an inch or 1/16th of an inch off the plate. Adjust your voltage until it's at that height, and you'll be getting good cuts.
Okay, another height control related question. How does the height control handle material or metal warpage as the steel heats from the constant heat?
Yeah. Once again, there's a lot of different height controls and machine manufacturers and CNC control manufacturers. A good height control has very good reaction time, and the material can warp and actually pop, and the height control will follow it. In fact, a really good height control, even though they're not designed to do it, think of corrugated metal roofing from an old barn. You can actually cut that and maintain 60 thousandths of an inch off the plate while you're cutting it up and down. The torch can move up and down that rapidly. But there are, in the last couple of years, there have been a lot of height controls. Everybody wants to get their piece of this pie, I think, and there are a lot of, you can go on eBay and just search height controls, and you can find height controls for $150, $200 that add to any CNC cutting table. They're better than no height control, but they're not going to be, you're going to have collisions with the plate, you're going to have incorrect heights. They're not as good as a height control that's integrated into the CNC control as another axis, and that's because those height controls also monitor the cut speed. So when the machine naturally has to slow down to go around a corner, instead of the height control diving, the CNC, the Z-axis knows that the speed has slowed down, and it will lock itself so it won't dive into the plate. And once the speed gets back up, it starts monitoring arc voltage again. You can't do that with a lot of the add-on height controls that are low cost. So just be careful with that. They're not all equal, I'd say.
Okay, it looks like we'll do 2 more questions, Jim, because it is the top of the hour right now. We have someone who likes to be prepared. They want to know which spare parts you recommend they keep on hand to minimize downtime.
Well, that's a big question. Spare parts for the plasma torch or spare parts for the CNC CNC machine? From plasma point of view, the parts that we call consumables, the nozzle, electrode, swirl ring, stuff in the torch, yes, you should keep those on part because hence the name consumables, they wear out as you're using them. Things like there's an O-ring that goes on the torch, on the plasma torch that should be taken care of. Now, as far as the CNC cutting table, it's best to talk to the manufacturer of the table that you might be buying or looking at or that you already own. Some of them might wear out drive belts, some of them might wear out bearings or something like that. So that most of the manufacturers can supply you a list of parts that you probably ought to keep on hand so you don't have downtime. Each one's a little different.
Okay, let's see if we have anything else here. Someone's asking, I think it's a Proforma. Have you ever heard of Proforma CNC or THC? I'm sorry. Oh, Proma THC.
Proma. Yeah, that's one of the low-cost import ones that I was talking about.
Okay.
Better than no THC for sure, but not as good as an integrated THC that's actually an additional axis on the CNC control. Okay. Yep. All right.
If you did ask, I think we got most of the questions. If you did ask a question and didn't get an answer, we will email you the answer to your question. So thank you all for joining us. Be sure and join us again on the 29th of this month. Jim is going to get into a lot more detail about machine motion and torch height controls and CNCs and all of those other questions.
Yeah. In fact, if anyone wants to email me at jim.colt@hypertherm.com with specific questions, maybe I haven't written that whole webinar.
Oh, okay.
Yet, and so maybe we can integrate some of the more popular questions into the webinar. So.
There you go. You can influence what Jim tells you in 2 weeks. All right. Thank you all for joining us. Bye-bye.